we're getting close. We're getting close to the end of the unit. We are getting close to the test. Test. What's today? Wednesday? Maybe Friday. See how that goes. All right, let's talk about radical equations. So before we talk about radical equations themselves, tell me, we've kind of done some of this before whenever we did square roots. If I had the square root of x equals 7, how would I solve that? In other words, what cancels that square root out? Y'all can do this. What cancels a square root out? What's the opposite of a square root? A squared. Somebody said it, a squared. If I do this, right, we've said over and over that this is 3, or the square root of 3 squared is 3. That's because these are opposite operations. They cancel each other out. Yeah. It's not. We're trying to do whatever we can to eliminate. And we did this whenever we did, y'all just may not remember, when we did things like this. How do we get rid of the exponent of 2 and we took the square root? We do that because these are opposite operations. Now we're just going backwards with it. So if we start with the radical, the exponent will cancel it out, okay? I don't want to do just a 1/2 because 1/2 is rewriting it, right? So what I want to do instead is raise it to whatever this root is, that exponent will cancel that out, okay? So if this was the third root of x equals 7, how would I solve that for x? Raise it to the third power. That's exactly right, because the third will cancel that out, and I will get x equals 7 to the third, whatever that comes up to. 729, I think, maybe. No, 363. Yeah. It's not? What is it? 43. Gosh dog it. All right. Yes, no, maybe so. All right, so here's what we're going to do. Steps to solving radical equations. The first thing we're going to do is we are going to isolate. What does isolate mean? Get by itself. We're going to isolate the radical, and then we're going to eliminate the radical. Eliminate means get rid of it, right? We're going to eliminate the radical using the exponent. And we're not going to go much further than that today, but some of these will get a little harder than others. So let's get into some examples and see what happens. Oh, and I guess step 3 would be solve. Ready? Okay. Y'all are no fun. First block's fun, third block's fun. Y'all are just.
Well, we want to take the day off. That's why we're not
Fun.
Look, can we vote very quickly and say
This is not a democracy.
the majority of the class agrees to take the day off? We'll start back tomorrow.
No, you can vote all you want, but it doesn't matter.
As live.
All right, square root of x plus 5. If I want to solve that for x, tell me what I do first.
Move the 5.
Move the 5 because I need to isolate the radical part. If I move the 5, I get square root of x equals 7. Okay, now I eliminate the radical. So square both sides and you get, what is 7 squared? 49. You think this is stupid, Charlie?
This is easy.
Oh, stupid easy. All right, then.
Slow it.
Solve for W.
We should move it.
Move the 10. Why? You should go sit down. Moving the 10 because I'm isolating the radical. Now what? Square it. Square it because, what's negative 7 squared, by the way? Is it negative 49 or positive 49? Positive. When you square negative, it becomes positive. So I've got 6W minus 5 equals 39, and you should be able to do it from there, no problem, right? Add 5 and divide by 6. Yes, I was fixing to say, let's crank this up. I have a sheet of problems because you're distracting me. I have a sheet of problems. They don't have the answers on them or anything, but just so that they come out nice and even. I'm not just spitting problems.
Straight facts.
Let's do another one kind of easy, and then we'll, not really, but just to show you that it could be written another way. I don't see a radical in this one. Why is it 1/3? So that really makes it a radical with what root? 3, right? I could change this to the third root of 7p minus 1 plus 11 equals 7. Now what do I do to solve it? Subtract 11. That's exactly right. If I subtract 11, I get the cubed root of 7p minus 1 equals negative 4. Now what? Cube both sides. What's negative 4 to the third power? That's right. This time it keeps the sign, and it keeps the sign because it's an odd numbered exponent, right? Yes. Logan, go sit your tail down and quit hitting people. Go. Now what? Correct. Divide by 7, and what do you get? All right, that's what happens if I have only, let's do this one. Charlie want to know, would it get any harder? It did. Why is this one harder? What should I do? Is the radical isolated? Yes, the radical is isolated. So my next step is to eliminate the radical, to square it. Okay, well, if I square this side and I square this side, now I've got 51 minus 5y equals, is it y squared minus 121? Say no, because it's not. No. I have to actually FOIL this out, right? I can't distribute an exponent when I'm adding or subtracting in the middle. I have to actually FOIL. So if you FOIL that out and clean it up a little bit, you get y squared minus 22y plus 121. But now I've got myself in a bit of a sticky situation because I have a quadratic, right? So we go back, we rewind back to chapter 1. How do you solve a quadratic? I'm going to make it equal 0 first, right? And I don't want to use quadratic formula unless I can't do anything else. That's my last resort. So I'm going to go ahead and move the 51 and the 5y over to make one side equal 0. And I hope you all remember how to do all this. We should definitely try to factor it before we do anything else. What's negative 22 plus 5? How about 121 minus 51? Can that be factored? What multiplies to 70 but adds to negative 17y? So if you still need to group this one, you don't necessarily have to group it because see my leading coefficient of 1, I can shortcut this one and say negative 10 and negative 7 are my two factors. So y minus 10, y minus 7. I still haven't finished this problem because I have to find what y equals, right?
Yes, Charlie. Attention, boy.
What does y equal? What are my two solutions? 10. What? Let's skip the slashing. All right. One other scenario that I need to show you, and then I'll be done. This is when you have one radical, but what happens if you have two radicals? No. So maybe I have something, stop. Like this. Okay. When you find yourself with two radicals, what you want to do is get them on either side of the equal sign. You got to separate them. Okay. So two radicals, we want to separate first. Not evaluate, we want to separate and get rid of the radicals. And then, of course, we solve. I'm being distracted myself. Separate them. So to separate them, I'm going to move this one to this side since it's negative, and I can just add it to make them equal. Am I going too fast? Too slow? No. If you got this and you don't need any more help, I'll go ahead and pass these out. But please do not interrupt me teaching to ask me a question about the homework because I'm probably going to get to it in a minute. When I move this over, I end up with 4 Now I've got them separated, but there's some other stuff in there, and that is okay. I'm going to go ahead and square both sides to get rid of the radicals, or try to. And let's see what happens. On the left side, this square is going to both, as on the right, okay? So you're right, 16 times, and then this goes away with that, 3q plus 15. 144. So if I distribute this 16, I get 48q plus 225 plus another 15, 10, or 240. Move the 48q. This is just your basic linear equation now. $96. Somebody's going to have to do that on your calculator because, oh no. I had it up through there. You can divide them both by 12. It'll give you 20 over 8, which would be 10 over 4, which would be 5 over 2. 2.5. That's what you said? You only foil if there's a plus or a minus in the middle that looks like if that had been 4 plus instead of 4 times, then I would have foiled. But because it's multiplying, then I can. Any other questions there? You will probably have at least one on your homework, by the way. You're going to foil it out and you're gonna end up with another radical. Yeah. You could have. You'd still end up with the same answer. Any other questions? That's it. I will say, if you get something that looks like this, and I'm pretty sure this shows up on the homework, and you square both sides, and I think, Caden, this is going to answer the question that you had. This is gone, right? That's easy to recognize. But on the right side, now I've got an add or subtract inside here, and so what I'm going to have to do is foil this one. But when I foil, watch what happens. I've got x plus 9. Square root of x times the square root of x is x minus the square root of x minus the square root of x plus 1. What is this? What's negative root x minus root x? Not multiplying them, though, but you're adding. So they're like radicals. There you go. Minus 2 root x plus 1. Here's the more complicated thing about this one is now I've done what I was supposed to do when there was 2 radicals and I separated them and tried to get rid of them, but another one's popped out in here. So now I'm going to have to go through the whole process of isolate the radical and then eliminate again. So now I'm back to the first scenario, which ends up, it's not very hard. It's just seeing that you have to do minus x minus 1 now I can isolate. Logan, can you please? So what does x equal? Now, your homework says check for extraneous solutions. We've talked